Just go on video and I'll share my screen. Let me start this screen share. Okay, I think we're ready to get started.
Right. Hello everyone. Welcome to the Kyverno Office Hour. So today we're going to cover the basics in Kyverno. What is the architecture of Kyverno? How to install that? What are the features available? Let me first introduce all the maintainers today. Chip, I'm not sure if you're on audio. Okay, let me introduce Chip real quick. Chip is one of the Kyverno maintainers. He's been helping on all the documentation changes, maintaining the website, as well as contributing the simple policies. And I'm shooting out. I'm a Kyverno maintainer as well. I'm mostly focusing on the development phase of Kyverno. And then today we have Jim McGuarty. Jim, do you want to introduce yourself?
Sure. Thank you, Shooting. Hey, everyone. This is Jim Bagwadia, co-founder at Nirmata and also a Kyverno maintainer.
Cool. As I mentioned earlier, Jim will cover the introduction of Kyverno, the basic architecture in Kyverno. Then Chip will walk us through the website, how to install Kyverno. Then we'll come back to the details of the Kyverno policy and new features.
All right. So yeah, let me just start by talking about why policies matter for Kubernetes and what we're talking about when we discuss Kubernetes policy management, right? So the very highest level, for any organization, policies typically are a set of rules that I use for governance, for managing various procedures. And in Kubernetes, policies serve as a contract between developers, security, and operations team, right? So it helps with automation, helps with security, helps with best practices, and makes it easy for these different roles to collaborate on Kubernetes itself. So some of the things policies can help you do is, of course, like the number one, use case is improving security. It's eliminating misconfigurations that might be occurring, creating proper separation of controls across roles, helping reduce complexity, in configuration management, things like that, and promoting best practices across your organization, right? So whether it's for workloads, for cluster configuration, and even other CRDs as they're being developed in Kubernetes, being able to make sure that best practices are followed. And then so, policies are not just for governance and enforcement, but also for self-service, for automation. So if you want to do things like enable certain certificates, or you want to make sure that there's proper defaults, and you want to kind of reduce the handoff between these different DevSec and Ops roles, policies serve as a very important piece of configuration which can be used to manage this, right? So several use cases and a growing number of things that are coming up, of course, in the community. So really exciting times to see this domain mature and policy management become a key focus in Kubernetes. All right, so let's, now that we understand a little bit about what policies are, why they're required, let's talk about why, Kyverno matters, right? So, with Kyverno, our tagline is Kubernetes native policy management. So, very often we get asked about, what does that mean, and why do you kind of claim Kyverno is Kubernetes native and maybe other, solutions are not, right? The other question we also that we get asked is, what does Kyverno mean? So, for before we dive into the answering the first question, Kyverno in Greek means govern. So that's how it applies to policy management itself, right? But getting back to the being Kubernetes native, really when you kind of think about what does it mean to be Kubernetes native, Of course, any solution that's designed for Kubernetes can claim to be Kubernetes native, right? Because it's focused on Kubernetes, and that's fair. But beyond that, Kyverno also utilizes Kubernetes APIs, and it can, it sits in the control plane, as you'll see, acts as an admission controller, and can leverage all of the Kubernetes APIs. It also extends, it also adds to the Kubernetes model. So it understands what schemas in Kubernetes look like and can extend those. And then it has first class understanding of how Kubernetes controllers and objects work. So things like pods and pod controllers, things like owner references, garbage collection, those are important aspects of Kubernetes. And Kyverno leverages these patterns in how it does policy management. And finally, and perhaps the most important thing for Kyverno is to be able to read the Kubernetes object schema and to be able to make sure that policies are written in a manner that they are conformant to that schema, and really policies start mimicking the object schema. So this is extremely powerful because if you understand what a pod looks like or a pod controller, like a deployment looks like, then Kubernetes or these Kyverno policies make a lot of sense, right? So I think that's super important to keep in mind. All right, so just kind of summarizing on that, right? So going to the why Kyverno. So the whole idea is to simplify policy management for Kubernetes. Kyverno is not a general purpose policy language or a policy tool. It's designed to manage policies in Kubernetes. It makes policies easy to read and write, makes results from policies again being easy to process, can validate, mutate, generate any configuration including custom resources, and can also leverage, all of the existing Kubernetes patterns, best practices, idioms, things like that, right? So that makes it very powerful, for Kubernetes policy management itself. So some, I think we talked about some of these use cases, but more specific to some things to point out, like what people are doing with Kyverno. One common use case is, basics like basic hygiene, like auto labeling, of resources, making sure that ownership is known, managing multi-tenancy or fine-grained RBAC, within Kubernetes, injecting sidecars, whether they're for like managing secrets or other sidecars, dynamic configuration based on rules. And a new use case, which we'll try and demonstrate, is image signing, image verification, which is also kind of supported now first class in Kyverno. So I'm going to next cover briefly the Kyverno architecture and then hand off to Chip, who's going to show us how to get started with Kyverno. And then we'll move into writing policies and managing policies. So oops, looks like the slide is misformatted a bit here, but if I think you can see the graphic. Your Kyverno acts as a admission controller, and what it does is it plugs in into the control plane of Kubernetes. So every API request in Kubernetes goes through several phases, right? The first phase is authentication and authorization. Then there's a mutating admission control. There's schema validation after that to make sure that the object is conformant to the Open API v3 schema. There's a validating admission control, that happens after the schema validation, and then finally the resource goes into etcd, right? So that these three phases, the mutating admission, the schema validation, the validating admission, that's called admission review, and Kyverno plugs in into that admission review phase. So when you install Kyverno, it installs, as through as a webhook into the API server, and it registers several controllers for mutating admission as well as validating admission control. And then as requests are being, are coming into Kyverno, it will automatically, apply policies based on your configured policy set inside of your cluster itself. So one interesting feature we'll see in 1.5 is also how the webhook itself can be, dynamically configured. Because previously in the prior releases, this was statically configured and managed, which means Kyverno would typically be wildcarded to get every request and that can take up a lot of processing resources itself. Um, Also, one thing to point out is there's more background controllers. There's a generate controller, which looks for resources to automatically generate. So when, for example, if a namespace is created, that goes through the API requests, but only after that namespace has been created, Kyverno can actually go and create the resources for that namespace, right? So that is triggered, using this generate controller, where it's watching for events coming from these resources and can then complete that policy for the namespace itself. There's also a policy controller which manages policies itself. So every time a new policy is added, Kyverno will apply that to all of the existing resources. It will create, background reports for these existing resources. And if you delete a policy, it will kind of clean up the reports and things, right? Or if you update a policy, it will reapply that to the existing resources. Keep in mind that Kyverno is designed to not impact existing workloads. So if let's say if you have, production workloads, you deploy a Kyverno policy, which, some of those production workloads may violate, Kyverno is not going to impact or bring down those workloads or block them in any manner, but it will report a violation, which you can see in the policy reports. And then after that, it's up to you how you kind of want to make corrections or what you want to do with it, right? So again, gives a lot of flexibility in terms of what can be done and how you can manage these policies at scale. So just quickly covering, the more a different view of the architecture. So if you kind of look at the more deployment time or the install view. So Kyverno, you're showing it kind of acts as an API service in Kubernetes. It receives these admission webhooks, and then there's a deployment which can have multiple pod instances, right? And then there's a config map for configuration, the service accounts for it to talk to the API server. There's a secret, of course, with that service account. And then there's a validating webhook configuration and the mutating webhook configuration, which is where it registers to receive these, the validating and mutating webhooks from the API server during admission control. There's also several custom resources that Kyverno creates and manages to be able to manage and apply policies and policy reports into your cluster. One thing to kind of point out is the policy report is a custom definite resource definition, which is being driven by the Kubernetes policy working group. So this policy report is not just used by Kyverno, but there's adapters being developed for other policy engines like Falco for runtime policies, also KubeBench for CIS benchmarks, things like that. So now you can have a standard way of reporting and seeing these policy results for your cluster. All right, so with that, let me stop sharing and I'll hand off to Chip. And while we're doing that, I don't know if there's any questions, anything we can answer before we move into the getting started section. So by the way, if there's any questions, please feel free, you can ask them on chat. We can help answer there. Otherwise, also, I think we can answer them later on the Kubernetes, the Kyverno Slack channel in the Kubernetes workspace. So over to you, Chip.
Thanks, Jim. Can somebody confirm that you're hearing and seeing me and also seeing my screen?
Yes, we can hear and see you, and I see the Kyverno.io page on your screen.
Cool. All right. Well, hi, everyone. My name's Chip. I'm one of the maintainers and also contributors. And want to just run quickly some of the resources that we have and also real quick getting started. So we've got a great website that's here, Kyverno.io, filled with super helpful documentation and some sample policies that'll help you get started. And I'll cover that in just a second. But just quickly looking at the documentation, we've got this broken down by all the categories that you really need, starting from the top down to the bottom. So learning about Kyverno and how to create your first policy, some of the things that Jim touched on and a lot more, including that nice graphic. A good, easy place to start. And there's even a quick start section that'll allow you to get Kyverno up and running in your cluster super quickly and easily with just a single command. And you can actually just copy and paste that kube control command and run it in your cluster. But so just pointing out the documentation that's available here at Kyverno.io. And then I'm actually going to flip over and run through a quick Kyverno installation in my terminal here and see what we get. So let me share that, and let's take a look at this. All right, so I am going to just quickly set up a K3D cluster. Kyverno works well on really any Kubernetes conformant cluster. Kind is a popular option, Minikube. I like to go with K3D. It's a little bit lighter weight, so I'm going to quickly spin up a cluster here, and then we'll go through the process of installing Kyverno, seeing what it creates for us, and then flip back over to the website and show some more of the resources that are available to really help and empower you get started running Kyverno in your environment in an easy way, and also enable you to go forward. So as soon as this creates here, going to get a nice fresh cluster, and then we'll go through, although there are a couple ways to go about doing it. You know, as I showed in the documentation, you can do it just with a raw YAML manifest, which is popular for just a quick start, or Helm is also another popular option that's probably a little more popular when it comes to running in a production type environment. So it's taking a little bit longer than I hoped here, so give it one more second, and then we'll wing out some Helm commands to get this running here. All right, looks like it's finally obliging here. So let's just do a get on nodes and make sure that we're good on our K3D, K3S cluster. All right, so I have already gone through this just a moment ago to make sure that we weren't going to have any demo goblins. So I am just going to go back and install Kyverno. So I'm going to install the version 1.4.3, which, as Jim mentioned, or will mention, 1.50 is right around the corner. And there's been a lot of great work put into that. But I'm going to go with the current release that's available. And in this one, we need to install the CRDs that are first. So I'm going to install those CRDs with the chart version is 203, but it corresponds to the Kyverno app version 143. Going to put it in a new namespace called Kyverno and go ahead and create that namespace. And once these CRDs are pulled down and installed, then we can go ahead and install the Kyverno app itself and see what it creates for us. And I think, all right, that's getting done. Moving a little bit slow here because of, I think, probably the screen sharing. All right, so now I'm going to flip over and run the Helm install command for the Kyverno app itself. Again, same version, 143, so we just installed the CRDs. Then we'll install the Kyverno app. And in 1.5, things are changing a little bit. We're making the installation process. We're kind of returning to the state where we had the CRDs that were collapsed in the same Helm chart. So this is only a temporary measure. When 1.50 is released, you'll just be able to do a simple Helm install Kyverno, and it'll get the CRDs. But the policies, which you can see here, by default, we're currently installing a baseline profile of the Kubernetes pod security standard policies, and they've been set to audit mode. In the future, in the very near future, this will still be available. You'll just have to run it as a second Helm install command. But for the time being, let's take a look at what we get. So by default, when we install Kyverno, and as I mentioned, this will just be an additional step in the next version. We get all of these cluster policies which are created for us, which correspond to the Kubernetes pod security standards, which are, if you recall, pod security policies. These are just a prescriptive way of providing best practices when it comes to security into your environment. So they've been set to audit mode, which means that if you create a resource and it violates one of these, for example, let's just take a look at this policy here. With it being in audit mode, it will not block a resource, but it will instead just simply warn you in a policy report. So in looking at this cluster policy, we can see that it is going to run in background mode, so it's going to scan the existing resources that you have in your cluster, but it's not going to impact them. And it's going to look for kinds that are pod, and it's going to look for if init containers exist. It's going to make sure that the privilege mode has been set to false. Same thing with containers. And then Kyverno conveniently creates these, what we call auto-gen rules, so that you can write a policy for pods, and Kyverno is intelligent enough to be able to translate that to the higher level controllers that we typically care about in Kubernetes world, which are things like daemon sets, deployments, jobs, stateful sets, etc. And it's translated that rule to work for those as well as just bare pods. So you can create bare pods and have this policy apply to them. You can create things like deployments and have Kyverno apply to those without you having to do anything else. So it's a really convenient thing. And here you see cron jobs were automatically created. So that's just a quick, very quick install guide through Kyverno. And you can see that it's running in our environment. Just see that it is in fact running. It automatically creates some policies for you. As I said, in the very near term, that'll still be available just with a separate step. So let me flip back over and go back to the website and show some of the resources that we've put together to really help empower you take Kyverno forward and really make hay with it. So I showed the documentation, but I'm also going to flip over, and as you see from the docs, there are all sorts of, in my opinion, in our opinion, I think, pretty good documentation on really how policies work, applying them, writing them, which goes through all of the possible combinations. But what I want to focus on with the next few minutes that I have are the actual policy library. So if you go over here to the policies page, you'll notice we've got 80 sample policies that are available for you to download and use right now. And those include the pod security standards that I showed just a moment ago. And that was only a small subset of what's available. But using these convenient filters that are on the left-hand side, you can quickly locate policies that are important to you and your environment and be able to really select something that makes sense and get off and running with it. So if we go, for example, and if we're interested in validation policies, we can select a policy category if it applies, but a minimum version if you don't really are trying to target a specific version. And then down in the subjects, these are all of the possible types of Kyverno policies that we have written. So pods probably the most popular. So if we check those two options, we've got 48 policies that just are around validation of pods. And as you can see here, these range in type from policies that are part of the pod security standards to some more capabilities that Kyverno has, like blocking pod execs, disallowing add capabilities, disallowing Helm tiller. So if we go into one of these, for example, we can get the entire policy YAML, which you can conveniently copy and paste again if you want, and just get up and running very quickly. And in many cases, because Kyverno has such low cognitive load in that you're not learning how to write a programming language, you're working with Kubernetes manifest as you've always done. If you do need to extend it, it's very simple to extend, and you probably don't need to spend weeks or months with Kyverno learning how to do it. But in many cases, the policies that you may want are already provided here, and you may not need to write anything. You could just extend something, and in many cases, these policies are ready-made just for you to drop in and run. So if we wanted to look at generate policies, we've got some generate policies here that allow you to do things like add a network policy, add quotas, If you wanted to look at mutation ability, because that's really what your use case is in your environment, you want to do things like add labels. Just simply select the filter type on the left, and you can quickly locate whatever those policies are. And also, not just with core Kubernetes resources, but as you can kind of see here, at least in one example, we have some cert manager policies. And so if you're interested in cert manager, you can just select that category and find policies that pertain to cert manager. And as time goes on, this is an open thing. Anyone can contribute to it. Policies that you wrote that you find particularly valuable and you want to supply to others. There's a submission process. We'll get those added to the website in the policies repo. They'll show up here, and then people can use these same abilities to filter and find policies that really help them and help you become more productive with Kyverno. So with that, let me toss it back over to Jim and Shooting.
Thanks, Chip. Yeah, by the way, one thing I should have mentioned up front is Shooting and I are actually at KubeCon in LA. So the folks you see walking around, we're kind of in this one, lounge area, and live streaming from there, right? So you may hear some background noise or some, you'll see folks going by. But yeah, so we have about 15 more minutes left, and there's a lot of things we wanted to cover. So we'll see how much we can get through. But let me pull up the slides again, and Shooting's going to walk us through what the policy definition looks like. And I hopefully we'll get to also talk about some of the new features coming in 1.5, or we'll certainly follow up in as like the release comes out, we'll have release notes and other things. So with that, let me hand off to Shooting to discuss, and I'm going to share the screen, but Shooting will be covering in terms of what Kyverno policies look like.
Okay, thank you, Jim. I think previously I had some trouble with my audio. I guess now it's better.
Yep.
All right, I'll cover the basics of what the is, what you can define in the policy, what are the current features we offer, and then hopefully we'll jump to the demos for the new features in 1.5. Okay, so now we can see this is a Kyverno policy, and in the policy you can define one or multiple rules, but then a particular rule you'll have this match and exclude block to select your target resource, right? The resources can be based on the client name, labels, selectors, annotations, even the user information, right? And you can also use the variable to query any attributes inside the incoming resources. And under the pattern of each rule, you can define either of these four, right? To mutate, validate, generate the resources, or even do the verify images. I think we got a lot of questions around that. We'll come back to that later. So if we move to the next one, here is an example of the mutate policy, right? So Kyverno policy uses this CRD, custom resource definition. And within the policy, you can see the rules. The rule here is to check the labels on the pod. And there under the validate pattern, it is what a pod looks like, right? If you know about the pod schema, it'll be straightforward to define a cluster policy. Okay, and in the validate policy, we support different patterns, right? The previous one we showed is the overlay style policy. And then in this example, we're showing that this is actually a deny rule. I think it's blocked by that tag, but it's a deny rule. And you're basically saying that I want to select on these kind of resources. And if I see it, or if Kyverno sees this request coming in, then you want Kyverno to block those initial requests, right? Because these resources are going to be deprecated or removed in 1.25. So you want to prevent your cluster to schedule any new resources using this deprecated API versions. Right, we have different patterns, operators supported in mutate policy, and Kyverno can also, invalidate policy, and Kyverno can also mutate the defaults as well. I think I mentioned this in one of my earlier talk in the SecurityCon, is that Kyverno provides this automation ability to mutate and generate resources, right? So in Mutate, we also support two different types of pattern. One is the JSON patch, which allows you to do the process updates. So if you know the path of that field that you're going to update, you can just write a JSON patch on that. Or you can similarly use the overlay style if you're familiar with the schema. Here you can see we have this overlay style mutate policy, which is to just mutate the port to 6443 if the name is matched to the secure style, right? And if we go to the next slide, I think we have the generate policy. In Kyverno, we have this generate ability to let you generate any new Kubernetes resources, including CR, like custom resource, upon various triggers. For example, if you create a new namespace, then Kyverno allows you to automate the creation of the network policy, cluster roles, cluster bindings to help you build the multi-tenancy cluster, and we can even clone the existing resources into the new namespace. And optionally, you can keep that data in sync, or if you don't want to sync that, you can turn it off in the policy as well. All right, that's the mutate validate and generate. So let me switch to Jim to cover the image verification since he's been working on that.
Yeah, so this is one of the newer features in Kyverno where we are integrating. There's another Linux Foundation project called Sigstore. For those of you who are following, KubeCon news, you've probably seen a lot of, discussion on Sigstore and what it does. So basically, the objective for Sigstore is to make, signing and verification simpler and easier for all sorts of artifacts. And here we're using a sub-project called Cosign, which is focused on, specifically on containers and using OCI compatible image registries to help manage, container signing, right? So what this policy is doing is it's again written at a pod level, but this will expand into all of the pod controllers and then you can specify an image pattern and you can have several rules for different images that you want to match. And then here in this use case, what all we're doing is basically showing a public key, which is allowing us to say that that image has to be signed with this particular key. Now you could repeat this. So if you have a particular image or if within a repo or within, a set of images. So, most enterprises, most organizations will have third-party images as well as internal images. So you can now separate this and say, okay, even third-party images, maybe they're signed by the vendor key, but they also have to be approved by our internal, IT operations team's key or our internal key to be allowed into the cluster, right? So these sort of things can be now easily done, and that verification happens before the pod is even allowed to execute or the cluster within the cluster.
Okay, thank you, Jim. So next, we're going to talk about how to use variables in Kyverno cluster. Within the Kyverno policy, basically, we support these two types of variables. One is the references that allows you to reference data in the current resources, and then we have this JMES pass expressions, right? It allows you to extract any of the information from the admission request, from the like incoming object, and we can also do the external lookup. So, and by default, if you have some values written in the config map, Kyverno builds a cache around the config map, and then we can look up the data inside the config map. The cache is just for fast lookup, or if you want to look up any other data in the Kubernetes resources, we also provide this ability to look up through the API server, right? If we go to the next slide, the next one, I think there is an example about the config map lookup and the API server lookup. So you can use that external data inside your policy and then for the further process. Right, here is an example of config map lookup. So under the rule, you see the context block, and under the context, you give the name, then you reference to the config map with the name and namespace. Then Kyverno will look up data from that config map. So in the policy body, you can use this context. So the name here is direction. So in my mutate rule, I'm saying that I want to mutate this label, my environment name, to use the directionary dot data dot in, right? That is something you define in the config map. And similarly, if you go to the next slides, I think we have the API server lookup. Similarly, you do the lookup. Here, you're looking up through the service, and then you're querying if there is any service type with load balancer. And if there is already a service with type load balancer, then you would want to reject any new services to be created in the cluster, right? So this Kyverno is able to look up external data inside the Kubernetes cluster, and you may wonder out like how to query external like tools or the servers. I think Jim, we had the discussion earlier, and there you would want to introduce a custom controllers, and then write that to either the config map or any of the Kubernetes resources. Then Kyverno would look up the data from there, right? This provides a secure layer to just to protect the data that Kyverno can look up. All right, let's look more features. I don't know if we want to. Yeah, let me quickly cover those. Um, Kyverno policy uses this policy report CRD, which is provided from Kubernetes policy workgroup. And if you have any policy configured in the background mode, Kyverno will scan all the existing resources and generate the policy reports, right? Since the policy report is just a CR in the Kubernetes cluster, you can get it through kubectl. And also you can install this policy reporter too. This is another open source project. I think Frank is working on that, and all other contributors. We have this policy reporter UI on the next slides. Right. The policy reporter is generated either from FECO, Kyverno, KubeBench, Privy, and any other adapters. And it also can be configured to send the notifications to different targets like Loki, Elasticsearch, Slack, and so on. Right. And in Kyverno, we also expose this endpoint to expose the Kyverno matrix. We provide some of the default matrix, and if you go to the next slide, we have the Kyverno dashboard configured. There you'll get all the matrix data, all the violations, even the cluster policy details. So all information is aggregated in this Grafana dashboard. All right. So if you don't want run Kyverno in the CLI, or if you want to automate some of the local tests or the mutate policies in your CI/CD pipeline, you can use this Kyverno CLI. In the CLI, we provide a bunch of commands to apply and test different policies locally. Okay, so yeah, let's go to the demo right now. We are working on 1.5 release, and I think, Jim, you have one demo about image verification, and we'll come back to the dynamic webhook, and for each features, if we got time.
Okay. Yeah, so just quickly introducing, what we're doing for image signing verification and how we're extending it in 1.5. So just to explain this process, so today, what's important, of course, supply chain security for software has become a critical, identified as a critical area for focus and for improvement. And the idea is that you should be able to sign container images as part of your CI/CD pipeline, as part of your build processes. And then you want to also be able to generate and sign metadata, like who, approved this particular image, who did the code review, or what is the vulnerability scan report look like, right? So those things can all be pushed as metadata to various, metadata repositories. In Toto is another Linux Foundation project which acts as a metadata repository. And in fact, they are producing an attestation format which is becoming widely adopted. and that we have also integrated into Kyverno. And then Kyverno can verify, to fetch and verify these, both the signatures and the attestations at admission controls. So I'm going to quickly show. I'll flip to my screen and one of our command lines, and I have here basically Kyverno installed. I have, so if I look at my cluster policies, I just have one cluster policy installed. And what this does right now is it checks image, it's set to enforce. So I'm going to actually, first delete this, and we'll see what happens without this. Um, so let's try -a. Oops. Yeah, let me fix that command. Okay, so we deleted the cluster policy. And so right now, if I kind of go ahead and I'll grab an image which we're going to use for this demo. And let me actually show you what that image repo registry looks like. It's basically in that registry. Right now, I have just, this is on GitHub container registry. And we're going to pull this, particular image and run it, right? So if I, kind of copy paste this and run that, it lets me create the pod. It's not verifying anything because there's no policies, right? So that's all I wanted to show you. And what we're going to do now is we'll actually use um, you know, cosign to sign this image, and then we'll come back and make sure that there's a policy to kind of install this. All right, so I'm going to use cosign from a command line. Now, of course, this could be as part of your CI/CD pipeline, whether you're using Tecton or Jenkins or some other tool. And I'm going to sign this image with a a public-private key pair, and then it's going to push something, and I'll show you what that looks like into our registry itself. So at this point, this is just cosign kind of doing its thing. That should be automated in your pipeline. And now if you go back into the same GitHub registry, and if I refresh, you'll see that there's a signature now that showed up, right? So this is where, there's a, basically cosign is signed and verified. And with the same, digest for the image, it has installed the signature. So let's go and install the policy to check images. And this is a very simple policy, similar to what we just looked at before. And we'll see what happens when we try and run it, with this, right? So we're back to having one policy. If we do get plus cpol, we should see that. And we see it's active and ready. And now I'm just going to try running that same pod again, which has the signature. Well, so in this case, yeah, so the reason why it failed is because it's saying it has an invalid signature. So, and I signed it with the key I signed it with did not match the key that it's expecting, right? So so what I wanted to show with this was also that it's not just, which signature you sign it with, but previously the error, of course, if you don't have a policy, it's not going to check anything. If you sign it and if you show like a different public key, it will show that. Let's actually go and see what this policy is looking for. And if you see check images, the reason why it failed is it's looking for two particular keys. So it found one of the keys I signed it with, but not the others. So very quickly, and I know we're running a bit short on time, but I'm gonna try and I'll show you what it means if I sign it with the other one. So I'm just gonna run the same command, and then I think I have in this directory, yeah, if I do keys and cosign key, it was going to sign and now upload my second signature, right? So keep in mind, with the first signature, it blocked it. Now we have two signatures, and now I want to run the same command again just to see what it will do. So what I'm expecting is if everything works, this is going to be allowed, and that's exactly what we saw, right? Because we were looking for these two signatures. The one new thing that's coming beyond just signing within this next release is also we are introducing this idea of attestation. So I think we just have a quick slide to show what that looks like. So there's attestations are just they contain predicates and other metadata. So this is an attestation, which is, for example, checking for vulnerabilities. It's making sure that your image was scanned in the last 7 days, and there's no high severity vulnerabilities, or if there's a kind of a list of allowed vulnerabilities, it will check against that, right? So I know we're coming up on time, so let me stop there in terms of these features. And Shooting, do you want to quickly talk about what dynamic webhooks and for each does?
Yeah, sure. The dynamic webhook we introduced in 1.5 is that, previously, before 1.5, Kyverno by default accepts all different kinds of admission requests, right? With this dynamic webhook support, Kyverno is now configured, or the webhook now is configured with the installed policy, right? In each policy, you have the matching kinds, and then we will update that and to configure the webhook and manage webhook dynamically. If you remove that kind of policy, then Kyverno will remove the matching resources from the webhook, right? And with the for each, I think previously there was an issue in Kyverno is that, when you operate with the operation or operate with the list, especially when you have the container, or if you want to add the volume or mount the volume to a specific container, it's not easy in Kernel, right? With this for each support, we're able to simplify the mutation validation of sub elements in resource declarations, right? And I think we have a few demos back in the last contributor meeting. And if you're interested, you can, or the recordings are available in the meeting agenda, meeting notes. Okay, to quickly summarize that, Kyverno is a native Kubernetes policy engine. It automates the resource configuration. It helps you to secure or to enforce the configuration. And Kyverno is also easy to get started with. As you can see, the policy is really, if you're familiar with Kubernetes resources, it's really started with. Okay. We're maintaining Kyverno community, the Slack channel under Kubernetes Slack, as well as in CF Slack channel. And all the documentations, the sample policies can be found from the Kyverno website. And if you have any questions or you have any interesting or use cases that you want to address, we have this monthly community meeting, and we meet weekly to discuss the feature requests or the issues from the contributors. All right. Thank you, everyone. I think we're running out of time.
How far is it from?
All right, so I don't think we have any questions on chat, but if there's anything else that anyone wants to ask, please find us on the Kubernetes Slack workspace in the Kyverno channel. Thanks, everyone. Bye bye.